Hey everyone, Math 103, we're working on section 6.1 today on simplifying rational expressions. Please start with a warm-up. First one, part A, we're multiplying exponentials. So we're using the product rule. We're going to add the exponents and get x to the 8th power. Second one, quotient rule. Here we're subtracting the exponents, x to the 8 minus 6, or x squared. Now with this one we're going to factor, so we need two numbers that multiply to get 72 and add to get negative 17. Since the middle term is negative, both of those numbers are going to be negative. And we got a positive number out here, so we know we have the same sign in both numbers. So those two numbers are 8 and 9. So we get x minus 8 times x minus 9. And the last one, we're going to use the AC method to factor this. AC is 4 times negative 15, which is negative 60. So we need two numbers to multiply to get negative 60 and add to get positive 17. That's going to be positive 20 and negative 3. So we'll split up that middle term and then factor by grouping. So the factored form is x plus 5 times 4x minus 3. So we're going to be working with rational expressions, and they are fractions with polynomials in the numerator and the denominator. And here are some examples. So just a single number 8, a constant, that's technically a polynomial. And x is a polynomial, so here we got a rational expression. Here we got things that look more like traditional polynomials here, x plus 5 over 6x plus 1. And then we've got some factorable polynomials over here, and these are the types we're going to be working with extensively today. So the idea in simplifying rational expressions is to factor both the numerator and denominator, and then cancel any matching factors. So here's an example of that. You got 10x squared on top, 25x to the 6th on the bottom. There's a couple different ways you can do this. If you'd like, we could just factor it all out. So we get 2 times 5 times x squared on top. And on the bottom, we get 5 times 5 times. And now I'm going to split this one up so that I match one of the other factors. So that I could write this as x squared times x to the 4th power using the properties of exponents. All right, now we can cancel anything that matches. The x squareds match, so those cancel. Then the 5's match. So what do we have left? We've got a 2 on top, and we have 5x to the 4th power on the bottom. So that's one way to do it. Another way to do it is to look at the numbers and variables separately. So let's simplify the fraction 10 25ths. And you can just do this with a calculator. I'm going to do it by hand by dividing top and bottom by 5, and that gives us the fraction 2/5. That matches what we have down here. And now we can do the x's. So we've got x to the 2nd power over x to the 6th power, which is x to the 2 minus 6, which is x to the negative 4 power, which is 1 over x to the 4 power. And then once we have these two things, we can just combine them together. Keep the numerators with numerators, 2 times 1 here, and then 5 times x to the 4th power is the denominator. So you can do it all at once, so you can do them separately. Lots of different ways to approach these. Your turn, number 1. So we can reduce that fraction 15/6 down to 5/2. And then for the x's, we got x to the 4th over x to the 7th. That is x to the 4 minus 7 power, which is x to the negative 3, which is 1 over x to the 3rd power. Now we can combine our numerators, 5 and 1 on top, that's just 5 on top, and then 2 times x to the 3rd power on the bottom. So 5 over 2x to the 3rd power. Your turn, number 2. I'm going to try the factoring method on this one. So I just broke everything up, and I broke up the x to the 8th and the x to the 4th times x to the 4th because it matches what I have down here. So 20 is 5 times 4. We got x to the 4th. And now I'm going to break up y to the 9th, and I want to match y squared, so I'm going to break that up to be y squared times y to the 7th. Right now we can cancel anything that matches. So the 4's cancel, x to the 4th cancels, y squared cancel. And what do we have left now? 3x to the 4th on top, and 5y to the 7th power on the bottom. Now, next example, we're going to see an expression involving some binomials. It's important to keep in mind that binomials are going to behave exactly the same way as variables or numbers. They'll cancel just like anything else. So the quotient rule applies to these just like it does with the exponent or with variables. So our base is x minus 2, and we got 3 and 5 as exponents. Quotient rule says we need to subtract these. So I've got x minus 2 to the 3 minus 5 power. And that is x minus 2 to the negative 2 power. And then we have to get rid of the negative exponent, so I'm going to put in the denominator. And you get x minus 2 squared. Your turn, number 3. Applying the quotient rule, our base is x plus 3. Our exponents are 5 and 6, so we're going to subtract those, and that gives us x plus 3 to the negative 1 power. Getting rid of the negative exponent, moving into the denominator, we get 1 over x plus 3. All right, for the next one, I'd like everybody to take a look at that binomial. We have x minus 1. And what I'm going to do is, just for fun, I'm going to factor out a negative 1. And when I do that, I'm going to change the sign on everything inside the parentheses. So this becomes negative x, and the negative 1 turns positive, so we get negative x plus 1. All right, now we're adding now, even though I have a negative number here, the operation is addition. And addition is commutative, so I can always change the order of the addition. So this equals negative of 1 minus x. So look what happened here. Here we have x minus 1, here we have 1 minus x. All we've done is change the order and make it negative. And that's something we can do all the time. If you ever have a binomial and you need to change the order, just factor out a negative 1. And we'll see how useful that can be in the next example. Now it may seem like you can't simplify this because we got different binomials there. They don't match. But we're going to make them match using that trick. So I'm going to factor a -1 out of the top. And now I can flip the order here. Oops, supposed to be minus here. Okay. All right, now we've got matching binomials on the top and the bottom. We're going to cancel those and just get -1. Your turn, number 4. All right, so I factored out my -1, cutting out a step there. Binomials cancel, we get -1. Now we're going to look at a little bit more complex expression. Now in this case, we're given binomials already that match, so we can just cancel those right out. All right, now we're going to reduce the fraction. 12/15 is equivalent to 4/5, and then x to the 6th over x squared is x to the 4th power. So our final answer will be 4x to the 4th over 5. Your turn, number 5. Our binomials cancel. Two eighths reduces to 1/4, and x to the 3rd over x to the 4th is 1 over x. Our final answer is 1 over 4x. Our next example is going to involve some factoring, and the strategy in each of these is the same, even if we're using different factoring strategies. It's always factor and cancel. Factor until we get something that matches, cancel the match, and then whatever remains is our answer. All right, first example of this strategy, you're going to do 4x squared plus 12x over 2x squared plus 8x. Now on top I can factor out 4x, and that gives us x plus 3. And on the bottom I can factor out 2x and get x plus 4. Now in this case we do not have matching binomials. And that's okay, they'll just end up in the final answer. But we do have some things that will cancel here. So our x's are going to cancel. And then 2 over 4, that reduces to just 2 on top. So what do we have left? We got 2 times x plus 3 on top and x plus 4 on the bottom. So sometimes we'll have binomials left over in the final answer. Your turn, number 6. So factoring the top, we can factor out 2x squared. And get 2x plus 3 in parentheses. And the bottom, we can factor out 4x squared. And get x minus 4 in parentheses. Now we can simplify these things we've factored out here. The x squareds are going to cancel. And then 2 over 4 reduces to 1/2. So what's left on top is 2x plus 3, and on the bottom we have 2 times x minus 4. Next example, x to the third minus 5x squared over 2x squared minus 10x. So on top, we got 2 x's here I can factor out. And get x minus 5 on top. And on the bottom, we can factor out 2x and get x minus 5. So with this one, we actually do have matching binomials, so we can cancel those. And then over here, we've got 2 x's on top and 1 on the bottom, so I'll cancel one of those. And 2 on the bottom, so we've canceled everything except for x on top over 2 on the bottom. So x over 2. Your turn, number 7. So on top we can factor out an x to get x times x plus 8. And on the bottom we can factor out a 3 to get 3 times x plus 8. Now our binomials cancel. And what we're left with is x on top and 3 on the bottom. X over 3. All right, now we're going to start exercising all those factoring techniques that we learned last term. We're going to start by simplifying this expression with trinomials on top and the bottom. All right, so we know what these are going to look like. A couple binomials multiplied on top and the bottom. So for the top trinomial, we need two numbers to multiply to get negative 15 and add to get negative 2. That's going to be negative 5 and 3. And on the bottom, we need two numbers to multiply to get negative 10, add to get negative 3. So that's x minus 5 times x plus 2. All right, now we've got a matching binomial. X minus 5s, those cancel, leaving just x plus 3 over x plus 2. Your turn, number 8. Factor in the top, we need two numbers to multiply to get 24, add to get 11. That is going to be 8 and 3. And on the bottom, we need two numbers to multiply to get 18, add to get 9. That is 6 and 3. So there's our matches, x plus 3 over x plus 3. And we are left with x plus 8 over x plus 6. So one nice thing about these problems, they have some hints built right into them. We know we're going to end up with a matching binomial. So if you factor both the top and the bottom and you got no matches, you should go back and check your work. All right, next up, we've got some a does not equal 1 trinomials. So if you're still struggling with these, this will be a good opportunity to practice these and master them. So I'm going to use the box method. No, I'm going to use the factoring by grouping method. So we're going to do 6 times negative 10 AC, and that is negative 60. Now we need two numbers to multiply to get negative 60 and add to get negative 11. So that's going to be negative 15 and 4. So for this one, we can break this up now into 6x squared minus 15x plus 4x minus 10. Now factoring by grouping, of the first two I can factor out 3x and get 2x minus 5. And over here I can factor out a 2 and 2x minus 5. So that gives us 2x minus 5 and 3x plus 2 for the top one. And this one, now I got AC method, 3 times negative 2 is negative 6. Now we need two numbers to multiply to get negative 6, add to get negative 1. So that is going to be negative 3 and 2. So this one we'll do 3x squared minus 3x plus 2x minus 2. Factoring out of 3x here, get x minus 1. Factoring out 2 here, we get x minus 1. So this factors into x minus 1 times 3x plus 2. All right, now I'm going to take these and fill them back in over here. So the top was here. So we get 2x minus 5 times 3x plus 2. And on the bottom, x minus 1 times 3x plus 2. So there's our match, 3x plus 2. We'll cancel these, leaving 2x minus 5 over x minus 1. And that brings us to your term number 9. So for the top one, using the AC method, we're going to do 4 times 9, that's 36. Now we need two numbers to multiply to get 36, add to get negative 15. And that is going to be negative 12 times negative 3. All right, so we'll break up that middle term and do negative 12 minus 3, and now factor by grouping. Factor out 4x out of the first one, and negative 3 out of the second one. So we get x minus 3 times 4x minus 3. And that's going to go up top. All right, now the bottom one, 4 times negative 9, that's negative 36. Now we need two numbers to multiply to get negative 36, add to get positive 9. So that's going to be 12 times negative 3. All right, factoring. Got 4x times x plus 3 minus 3 times x plus 3. So we got x plus 3 times 4x minus 3. So there's our matching binomials. 4x minus 3, those are gone. Leaving behind only x minus 3 over x plus 3. Now with any factoring problem, we're always going to start by factoring out the GCF first. So make sure you look for that when doing these problems. The next one will require it. So out of the top, let's see what we can factor out here. Got 2 x's in each of these and a 3, so we'll factor out 3x squared. And get x squared minus 4. And on the bottom, looks like all the numbers, greatest common factor of 9. And we have an x in each term, so we'll factor out 9x. And get x squared plus 3x minus 10. All right, now that we've factored out the GCF, now we see we have some factorable expressions here. Difference of squares. So it's going to factor into x plus 2 times x minus 2. And here we need two numbers to multiply to get negative 10, add to get 3. So that's going to be x plus 5 times x minus 2. Now I've got some things to cancel. X minus 2, those binomials match. These do not. We'll have to keep those. Here we've got 2 x's on top, 1 on the bottom, so we'll get rid of one of those. And then 3 over 9. That simplifies to 1/3. So let's see what we have left here. We've got 1 times x on top times x plus 2. So x times x plus 2 in the numerator. And the denominator, we've got 3 times x plus 5. Your turn, number 10. So on the top, we can factor out 6x. And get x squared minus 2x minus 3. On the bottom, we can factor out 3x squared. And get x squared minus 9. Now, factoring the top, x squared minus 2x minus 3. We need two numbers that multiply to get negative 3, add to get negative 2. So that's going to be x minus 3 times x plus 1. And on the bottom, we got 3x squared. And difference is squares, so that's going to be x minus 3, x plus 3. There's our matching binomial. X minus 3's are gone. Over here, we got two x's on the bottom, one on the top, so those are going to go away, leaving just one x on the bottom. And then 6 over 3 turns into 2 over 1. So what remains on top? 2 times x plus 1. And on the bottom, we got x times x plus 3. On the last page, you got your turn number 11. There are 4 increasingly challenging problems. So please go through and work on those, and I will put up the solutions. Part A. We need two numbers to multiply to get negative 16 and add to get 6. That's going to be 8 and negative 2. X plus 8 times x minus 2 on top. And the bottom, we need two numbers to multiply to get negative 48 and add to get 2. So that is going to be x plus 8 times x minus 6. So we can cancel the matching binomials, x plus 8, and we get x minus 2 over x minus 6. B. We need two numbers to multiply to get negative 18, add to get 3. That is going to be x plus 6 times x minus 3 on top. And the bottom, we need two numbers to multiply to get 27, add to get negative 12. So that is going to be x minus 6 times x, let's see, oops, 9, and x minus 3. So our matching binomial is x minus 3. Those go away. And we're left with x plus 6 over x minus 9. All right, now we've got some a does not equal 1 trinomials, so we're going to use the AC method here. 2 times negative 12 is negative 24. So we need two numbers to multiply to get negative 24, add to get negative 5. That's going to be negative 8 and 3. All right, now we're going to use the factoring by grouping. So out of the first two, we can factor out a 2x and get x minus 4. And the second one, we can factor out a 3 and get x minus 4. So x minus 4 times 2x plus 3. And that's going to be our numerator. Now I'll do the same thing in the denominator. 2 times 18 is 36. We need two numbers to multiply to get 36 and to get 15. That's going to be 12 and 3. All right, so that gives us 2x squared plus 12x plus 3x plus 18. Factor out a 2x from the first two terms here and get x plus 6. And we'll factor out a 3 from the second two terms and get x plus 6. So that's x plus 6 times 2x plus 3. All right, so this thing then turns into these two binomials in the numerator, and in the denominator, x plus 6 times 2x plus 3. There's our matches. And what remains is x minus 4 over x plus 6. Part D. Here's one where we need to factor out a GCF first. So out of the top, looks like we can factor out 3x. That gives us 8x squared minus 6x minus 9. And on the bottom, looks like we can factor out 3x here as well. And that gives us 6x squared minus x minus 12. All right, well, that's nice. We have an easy cancellation here. 3x over 3x, those are going to go away, leaving just these two. So we'll need to factor these two. All right, top one. 8 times negative 9 is negative 72. Negative 72, we need two numbers to multiply to get negative 72 and add to get negative 6. So that's going to be negative 12 and positive 6. So let's factor by grouping here. 8x squared minus 12x plus 6x minus 9. So out of the first two, I can factor out 4x and get 2x minus 3. And out of the second two, I can factor out 3 and get 2x minus 3. So this is 2x minus 3 times 4x plus 3. All right, there's the top one. I'll do this one. We got 6 times negative 2, that's negative 72. So we need two numbers to multiply to get negative 72 and add to get negative x, or negative 1. So that's going to be negative 9 and 8. 6x squared minus 9x plus 8x minus 12. All right, factor my grouping. Take out a 3x and get 2x minus 3. And here we'll factor out a 4 and get 2x minus 3. So this is 2x minus 3 times 3x plus 4. All right, there's our numerator, there's our denominator. So we'll rewrite this as 2x minus 3 times 4x plus 3. Oops. Over 2x minus 3 times 3x plus 4. All right, now we got a match here. 2x minus 3's cancel, and that leaves us 4x plus 3 over 3x plus 4. And that is it for today, everyone. Hope you all have a great day.